Welcome to Managing Machine Learning Projects. My case is the following. Opportunity evaluation. We do have two main platforms for private car sales in Germany, which is Oktober and mobile.de. They have hardly no USP to attract private customers, so there's no differentiation between these two platforms. So we do have, let's say, a business problem and a customer problem. The business problem is that, as I said, we don't have a differentiation between the two main platforms, so we have a high competition and both platforms seek for USP. And for the private customer, they don't have a lot of time to place ads, so they need to spend a lot of time placing ads online, especially as they are now professionals and most likely doing it only once every 5 years, roughly. So, as I said, does somebody care? We're looking for differentiation opportunities on the business side, and we're looking for something to speed up the whole process and also help private customers placing the ads online. How can machine learning solve that issue? We would like to use image classification to speed up the process of placing ads. The business understanding problem. Define the problem. As a user, I want to easily place my ad for an used car online. I do not want to sell it to a retailer, as I know I will get a lower price for it. I'm not a professional car retailer, so placing my ad costs a lot of time for me. So our target user in this case is the private customer in Europe wanting to sell their own car. Today it's solved either privates sell it customer to customer or customer to business, which is a lot of manual work for privates because they do have to place the ad manually on some platforms. Privates can also sell the car while buying a new one from a professional retailer, however they get little prices for that. It's less work, but the gain is also little. As I said, we have a tight competitive landscape in Germany, and it would be a huge gain for one of the platforms to create that USP to make it easier for privates to sell their car. The success criteria in terms of outcomes is increase in active private users, increase in private online ads, increase in active business users, and also increase in sales prices for private users. The output metric for our model would be mean squared error. The relevant factors, we do need to have access to a car inventory database. We need to make sure that changes in the car industry, such as the rise of electric cars, are reflected in the car inventory. And we also need to check if there is a development of lease car market or business car market so that we do not have as much private car sales anymore. The solution concept. So I would like to use image and text detection and classification. So in Germany we do have a car document, which you can see here on the screenshot, which holds all relevant information. Plus we do have a car identifier, which is called HSN TSN, the OEM's key number, which stores a lot of information regarding the car inventory. So the users take a picture of this car document, upload it to the platform, and automatically via image classification and text detection, we automatically add all the car inventory to the ad, so the user does not have to do it on his own. And we also make sure that the process is sped up a lot, and we all have the relevant car information. So the user validation of the solution, I would first of all create a prototype, so creating a simple input user UI and a mock service to add the car inventory data. And then I would conduct lab tests, so the users using the prototype, users can enter the registration process, can take a picture of the car document and upload it, and get back the car inventory as a result. For the upload service and also for the getting back the car inventory as a result, I would use mock services in the first place. We don't need to add our real databases already. So it's the ease of use and the availability of car documents are my success criteria. Every car has to hold a car document. In Germany, car holders need to take the car document whenever they drive. So I assume that we have a high availability of the car document. And the second thing, I would conduct some expert interviews with industry experts regarding the availability and precision of the car inventory stored with HSN TSN. Then the machine learning system design decisions. factors. So first of all, regarding the solution, we do have an online application which is available both mobile and desktop. So because we know that a lot of people are doing the registration of their car on a mobile device, but we can assume good internet connection. If we have a loss of connection, it's not that bad. We need to make sure that we store all the data which has already been input in the browser, which is enough, so that the user can resume the process later. We don't have any sensitive personal data, and the data is evolving or changing rather slow. So we don't have so many new models coming up on a high frequency. So usually we have two points in time during the year where we have new models released, and the car document is a governmental paper which has little to no changes. So the system design decisions, we can use a cloud system because we don't have sensitive data involved, and we can assume that we have a good connection. We use offline learning because we only have slow or little changes in the input data, and we need to use online prediction because the system needs to react upon each new user request, because the prediction is solely based on the specific car document the user is uploading. The risks in production. I think the highest risk is the image quality. We need to train the data with poor quality because the users take the pictures. They are not professional photographers. We need to assume that we have bad lighting, rough surfaces where the car document is placed on, cameras with poor resolution. The car documents can be really worn or wrecked on a bad state, as usually people take this car document in a lot of different places, like in the back of the pockets, in some purses. They have it stored in the car department somewhere, and it might be really old because it is issued the first time when the car is registered for the first time, and so it can be like 20 years old. We have the second risk is the HSN TSN data. This is the, as I said, OEM key number, which stores all car features. However, I think this risk is quite low because we do have databases which are available via API. We need to check, as I said, I would like to take these industry expert interviews beforehand, that the database is updated, especially with the new OEMs like from China. Then the training skew risk, I don't expect it, as I said, HSN TSN is a database and the real car documents, and we really need to make sure that we mimic, when we're training the model, that we mimic the poor image quality as described before. The latency, I don't expect this as a risk, as we have only one image which is being uploaded, and we can still add a limit to image size for upload if it is needed. Data drift or concept drift I also don't expect, as HSN TSN is a standard and governmentally requested data point, and the car document is a governmental document with little to no changes at all. New technologies such as e-cars or also hydrogen cars are already reflected in HSN TSN, and as I said, we're going to apply offline learning so that we can adapt to new data fields in the car document. And we can also, we don't need to assume that the car document will be replaced in a short term via a digital document. Thanks.